Hi everyone, this is Ramesh and welcome to my channel. Today we are going to learn in the real number chapter. There is one subtopic logarithms in 10th class SCRT books of Telangana. Here in the exercise number 5 we completely learn about the logarithms. It's an entirely new concept in the 10th class. So let me tell you why these logarithms are used. Logarithms are used for the bigger calculations where we cannot be write the numbers directly. To write in the short form, we use the logarithms. Actually, logarithms are mainly inverse of exponential functions. Generally, historically, the maths scholars used to use these logarithms to express the multiplication functions into additions and division functions into subtractions. Before they invite the calculators, calculators, instead of doing multiplications, they used to turn it up into additions. Additions are very easy to calculate comparing to the multiplications. In the same way, the divisions they used to be converted into the subtractions. Here, divisions is difficult to do it, so they used to convert this into the subtractions. So it is very easy to calculate. Before they invent the calculator, they used to use this as well. So in this video, I'll tell you the complete introduction about the logarithms and some examples and where we use in a day-to-day life these logarithms. This all we'll learn in this video. So let's start. Here logarithms, the perfect definition of logarithm I will explain you. Then based on this I will give you several examples so that you can understand what is logarithm. So watch this video till the end, should not skip it. Okay, let's see that logarithm. If a and b are two real numbers, two positive real numbers, not negative real numbers here. If a and b are two positive real numbers, and here where a is not equal to 1, and if a to the power of x equal to b, then x is a logarithm of b of base a. I hope you didn't understand anything. Let me explain you what is this. Let's say take this a to the power of x equal to b. A to the power of x equal to b. It is in the form of exponential. It is in the form of exponential. Let us convert into the logarithm form. How to convert into the logarithm form? Let me explain. So it can be converted to the logarithm forms where this x equal to the logarithms shortly we write as a log. Logarithms will shortly be write as a log. Log b base a. Log b base a. We read this as log b of base a. Here this we need to study as a base. The top one. This two we have to read at a time. Log b. It is a base. Base of this logarithm. So here base a. So it is a logarithm form. This is the exponential form and this is logarithm form. Exponential form and logarithm forms. So try to remember. Let me give you some examples to be understand these. So these are very important. One is exponential form where a to the power of x equal to b. It can be converted to the x equal to log b base a. So this will be happens if and only if. That means if it is in the exponential form, if we need it, we can convert it to the logarithm forms. Suppose a problem in the logarithm form, we can also convert it to the exponential form according to the problems. So it happens if and only if. If it happens, it also satisfy this condition. If it happened, it also satisfy this condition. So let me take some questions to understand here. Can you tell that what is the value of log 25 base 5? What is the value of this? Can we explain? So it's very easy to while doing it. Let's go for the normal solution once. Let's go for a normal solution. Here, let us assume that log 25 base 5 equal to suppose x. It has some x equal. Then let's take that. See, it is in the logarithm form. Can we convert it to the exponential form as it? Yes, we can convert it to the exponential form. Yes, we can convert it to the exponential form. Then this 25 is equal to, this is power of, yes, 5 to the power of x. We can write. See, where a to the power of x, it is in the form of a to the power of x equal to b. Then here x equal to log b base a. Here it is in the logarithm form. We change it into the exponential form. Nothing to worry. This log value we have to write here. Then this base we have to transfer to the RHS side. When you transfer this RHS side, see, it will be whatever the RHS side, it will be in the powers. Comes in the powers. As we know that this 25 can be converted as a pi square equal to here 5 to the power of x. As we have studied, that is when bases are equal, then exponents are also equal. Then here the bases are equal at 5 and 5. Then exponents are also will be equal, that is x equal to 2. As we can write that, what is x here? This is x. Then here log 25 base 5 equal to 2. Let's take one more question to be understand you more better again. Let's take one more question, that is log 8 base 2 value is what? Log 8 base 2 value is what? Let's go for the normal solution once. So these are normal process to be do it. Logarithm forms to exponential forms. Let us assume this log 8 base 2 equal to x. Log 8 base 2 equal to x. Then let us change it to the exponential form. This 8 you write here. Then this is 2 to the power of x. Yes, this 8 can be written as 2 to the power of 3. So here 2 to the power of x. When bases are equal, then exponents are also equal. Then x equal to 3. As therefore the log 8 base 2 equal to 3. So let me take the one more question to be understand you more better way again. So here the third one, log 5 base 25. In this case, what is the value of log 5 of base 25? What is the value of this? Let's go for that. If you understand, I will tell you the short way how we get the answer later. Then let us assume this log 5 base 25 equal to x. In the same way we write here 5 equal to 25 to the power of x. 25 to the power of x. As here 25. This 25, this 5 cannot be written as a base 25. Here is a base, is an exponent. So here 25, here 5 cannot be written as a 25, but 25 can be written as a 5. So let us change it. This 5 equal to, this 5 square is 25 and whole to the power of there is a x. It is in the form of a to the power of m whole to the power of n. A to the power of m whole to the power of m. By the using the laws of exponents, we get here 5 to the power of 1 we can write this. Here a to the power of m into whole to the power of n equal to a to the power of mn, that is 5 to the power of 2x. Here bases are equal and the exponents are equal. Else we can get here 2x equal to 1. Because here 2x equal to this one and x value equal to 1 by 2. Therefore, the log 5 base 25 equal to 1 by 2. Okay, let we observe this once what we get actually. See that here, what is the value of log 5? Log 25 base 5. This 25, here base we need to observe. Base can be converted in the form of 25. Yes, by do it 5 square. 5 square is 25. That means here, whatever, if you do it a square, we get 25. No? Then these both values are equal. At what? At 5 square, this power 2. So answer become 2. See that? Here 2 to the power of 3 is 80. So when you write this 2 cube, here power if you write 3, this answers will become same. That log value and base value become same. Then at the 3 it will be same. So answer will be 3. In the same way when come to here, here it comes here 5, here 25. However 25 we need to be converted into the 5s. How can we do it? Here 5 square We can 5 square we can write. 5 square. Here the power is 1. Here it is 5 square. So 1 and 2. It is the 1 by 2. The answer become a 1 by 2. In the further questions you can understand that how we can solve this again. So let me take some more questions to be understand more better way. So mainly you need to be observe this clearly to be understand. So logarithms mainly used in our real life, day to day real life. I will also tell you where we use this actually. Let's take some more questions. Here, let me go for the fourth question. Can anybody tell that what is the value of log 100 of base 10? Yes, 10 we can make it into 100 by doing 10 square. The value will be 2. So let us solve in the general method that log 100 of base 10 equal to x. So it is in the form of logarithm. Let's convert it to the exponential form. This 100 equal to 10 to the power of x. Then here 100 can be written as 10 square. It is 10 to the power of x. Then here bases are equal. Then exponents also will be equal, and x equal to 2. Therefore here log 100 of base 10 equal to 2. And can you expect here directly what will be the answer of log 1000 of base 10? Yes, you can guess that. What is the value of log 1000 of base 10? Yes, that is absolutely as 3. Guess is correct. Let's go for the general process that log 1000 of base 10 equal to x. Here 10 to the power of 3 will give us 1000. So answer will be here the power is 3. So the answer will be 3 here. Let's see. Let us convert this into the exponential form. Here 1000 is equal to 10 to the power of x. 1000 we can write as 10 to the power of 3. 10 cube is 1000. 10 into 10 into 10. That is give us 1000. Here 10 to the power of x. When bases are equal, then exponents also will be equal. Hence x equal to 3. Therefore log 1000 of base 10 equal to 3. So let's take the one more question. Now as we can guess it, what is the value of log 10,000 of base 10? Yes, here you can tell that the log 10,000 of base 10 value is 4. Yes, let's go for once that you are getting both, but this will give us lot of information. So you can also learn the many things from these values actually. So I want to tell you where this is very useful now. This 10,000 we can write as 10 to the power of 4, and this is equal to 10 to the power of x. X equal to that is 4. Therefore log 10,000 base 10 equal to value is 4. Here we can see the fuse. That means the logs very large numbers. As we are converted to the general numbers 2, 3, 4. As a like natural numbers we got it. So here these values, that means when you go for one example I will tell you where these logarithms are useful. Again some more examples I will take in this. So when you see that suppose Japan country is affected by earthquake. It was recorded on the Richter scale as 6.0, 7.0. Do you know what is the Richter scale actually? The Richter scale always in the form of the logarithms actually. They will give you, suppose it was recorded as 6.0. On the Richter scale, the earthquake was recorded as 6.0. Do you know what is meaning of 6.0 children? Here it is power of 10 log 10 to the power of 6 log 10 to the power of 6 of base 6. You know how effective it is if you write 10 to the power of 6 zeros, that means 10 into 10 into 10 into 10 into 10 into 10. Yes, that will be equal to 1, 3, 4, 5, 6. It will be affected this much of effective gets 10 to the power of, and the Richter scale if you observe as a 4.0, the earthquake as recorded on the Richter scale is a 4.0 suppose. Always the Richter scale will be giving as a 3.4 as a like a natural numbers only, like a 3 or 4 or 5. It was regarded like that, means it is the power of tens. It is so that much of effective. So see that suppose in India the earthquake is recorded as a 2, suppose 2.0, and in the Japan the earthquake is recorded as a 3.0. In India it was recorded as a 2.0, and the Richter scale in the Japan it was recorded as a 3.0. That means you know the difference here only one digit? No, it shows that here 10 to the power of 2 that equal to 100 times. Here 10 to the power of 3 that equal to 1000. That means it is 10 times more than that effective. So here logarithms will also use. It is the one of the use of finding earthquakes. Well, telling about the earthquakes, how it is effective, logarithms are useful there. Again, let me tell you here logarithm. These are two values. This log 100 base 10 equal to 2, log 1000 base 10 equal to 3, log 10,000 base 10 equal to 4. These 2, 3, 4 are known as a natural numbers. That means it's also known as the real numbers. So some of the logarithms are real numbers and some of the logarithms are not real numbers. They are, that means irrational numbers. Some of them are irrational numbers, some of the logarithm values are rational numbers, or some of the logarithm values are irrational numbers. So here I will tell you where the value will get exactly, where we can express in the exponential form and get exact value. There we get a rational number, or else we get a irrational numbers. So that I will tell you some of the examples here. Let's take here one more example. Log 1 of base 10 value is what? Log 1 of base 10 is equal to what actually? Let's see the value. Let's go for the one general solution here. Log 1 of base 10 equal to x. It can be write as 1 equal to 10 to the power of x. So just observe here. At what value? Here 1 cannot be converted as a base 10, but 10 to the power of x. At what value of x? It equal to 1. Exactly. When x equal to 0 here, then 1 equal to 10 to the power of 0. If you raise 10 to the power of 0, that equal to 1. Hence, then x equal to, it's x equal to 0. At value of x equal to 0, the log 1 base 10 equal to 0. Simple. Log 1 of base 10 equal to 0. Not only log 1 of base 10, log 1 of any base. Remember, this is very important. Log 1 of any base always 0. If you see log 1, write as a 0. That answer always 0. So it is a real number. Let's see where the logarithms are not possible actually. This is also very important concept to understand our definition actually. Let's go for the log minus 2 to the power of base 3 equal to what? Log minus 2 of base 3 equal to what? Let's see here. Log minus 2 base 3 equal to x. Then minus 2 equal to 3 to the power of x. Then you see this minus 2 cannot be write as a base 3, and this 3 cannot be write as a minus 2 as a base. So here this solution cannot be defined. We can't find out any answer here. We get the x value here? No, it's not possible to get the x value. So in this situation, it is known as a irrational number. Irrational number. We cannot be defined this. Cannot be defined. Cannot be defined this value. We cannot define this value. So the log minus 2 of base 3 cannot be defined. Why? Here we said that a and b are two positive real number. Positive real number I said. Here a and b. Here a and b should be a positive real numbers. But here we have a negative real number. So in the case of negative real numbers, logarithms will not be worked out. Remember that. With the case of negative numbers, logarithm will not be worked out. We get a answer as a not defined. Let's see that here we have studied when a and b are two positive real numbers and a is not equal to 1, When a is not equal to 1 means this should not be equal to 1. When base log 1 value is 0, when base become 1, when base is become a 1, what happens here? In the definition we mentioned clearly that if a and b are two positive real numbers, when a is not equal to 1, then a to the power of x equal to b, it is a, then the x is a logarithm of b of base a, we said, but base a should not be equal to 1. If it is 1, what happens? Let's see by taking one example here so that we can conclude this. Log pi of base 1 equal to 1. Let's see the solution of these ones. Log pi of base 1. If log 1 value is 0, if base is 1, what happens? Let's see here. So let's write log pi of base 1 equal to x. Then pi equal to 1 to the power of x. Pi equal to 1 to the power of x. Can we write this? See. So here pi can you express as 1? Phi can you express as a 1? No. Here 1 can be expressed as a phi? No. It's also not possible. This also we call as a irrational number. Irrational number. We don't get any positive real number here. You won't get any positive real numbers. Okay. So it's called as a irrational numbers only. We will not get any perfect values here. So we get irrational numbers. Or else in the before examples I told you completely that 6 examples are real numbers. That means they are rational numbers. The combination of rational and irrational numbers is known as the real numbers. Where we get the rational numbers and where we get the irrational numbers, you need to be find out children. This also cannot be defined. Cannot be defined. This answer also cannot be defined, children. I hope you understand this. Let me tell you some more uses of these logarithms where we use it. In the Sensex, you can see the Bombay Stock Exchange, Sensex, Nifty, Shifty, SIFT. There the large calculations, bigger calculations will be used. So there the logarithms will be used. And sometimes your physical subject, physical science subject, where you want to find out the pH value of water. pH value of water in the sense, what is the value of, what is the meaning of pH? The power of hydrogens. The power of hydrogens in the water. So hydrogens in the sense, what molecules of acidic and basic measures of water, calculating acidic and basic in the water. The substance, what substance it has to calculating, we use the pH value. As we know that the normal water, natural water pH value is 7. If it is less than 7, it is a acidic. It's more than 7. That's the basic nature. So this will study in the logarithm forms only. So normally this will be in the form of 0 to 14 actually. The pH value is 0 to 14. So this you will study in the physical subjects. Then other than that, binary systems where we use in the computers, the binary systems also in the logarithm forms only. And mobile phones, if you see the mobile phone, then you open the calculators. In the calculator there is a logarithm, calculations are there. These all problems you can also try in the mobile also. Once what is solved here, you go to the mobile and type there, the logarithm symbol will be there. Tap the logarithm symbol and find out the values what is solved here. You get the exact value. And next in the we use calculators also, some kind of calculators where engineers will use it to do the calculations. Engineers to construct the buildings or planning, they will be using the logarithms there. Then next doctors will use the logarithms to know the number of cells in the body, how many cells are there in the body. It will be a bigger number, knows there you will use the logarithms. And astronomers to find out the distance from earth to moon, that will be 10 to the power of 8, log 10 to the power of 8, expressing in the exponential form. There they will use the logarithms. And finding distance between the one star to one star, what is the distance between the two planets and stars, there we use the logarithms. So I hope you understand what is logarithm. So in the next video I will tell you the all complete formulas with many examples. Complete, there are 10 formulas only, 8 to 9 formulas or 10 formulas. That 10 formulas I will explain you with a lot of examples so that you get a complete idea about logarithms. Till that time, keep smiling. Bye children.